or orbit valves, which are using when we face with high differential temperature. For example, the valve installed in the pipeline in the upstream, the catalyst or the solid desiccant are regenerated at the temperature of 300 degrees centigrade. In the downstream, our operation is 25 degrees centigrade as a dehydration unit in the gas refinery. Which valve can stand this thermal tension? 275 degrees centigrade across maximum 30-40 centimeters. It's difficult for that. And also the sealing. Mechanical guys know about that. The sealing of the valve will destroy because of this high temperature. For example, assume this is a ball valve. This side of the ball valve introduced with, to the 25 degrees centigrade of the material, and this side is maybe 300. In the oil refinery, sometimes in the isomax, you face with the temperature higher than this one, also the pressure. This thermal tension, you know, we have a volumetric extension, thermal extension. The volumetric thermal extension of the material in this hot side is much more than this one. Push the pressure on the valve body and destroy your valve sealing. We designed this valve to completely cut out the fluid because we face with a different type of the fluid. The character of the valve is to cut out the fluid. When the valves are closed, we can recognize this valve is in right condition or not. Which type of valve can stand this high temperature? Crank valves. I will explain you in the rest of the slide. You can find how to install the crank valve, how to recognize which which side of the valve is upstream, downstream, and every other valve to install in right direction without any document or so on. Okay, ramp up in heater and reboiler. You are always working with the cooling media, heating media like steam and hot oil. Cooling media, refrigerant, for example, propane, R-type refrigerant, you face with them. Okay, if you want to put in service a boiler, for example, for hot oil as your processing facility, what happens to that if you increase the temperature 100 degrees centigrade per hour? Thermal tension destroy your materials, destroy your sealing in the exchanger, and reduce the efficiency of your equipment. What is the solution? There is an acceptable temperature gradient for this equipment, for the startup. Ramp up for the heating media and ramp down for the cooling media. Okay. For example, for the heating media, we are alone. When we are working with the hot oil, the maximum increased temperature per hour is 40 degrees centigrade per hour. When we want to increase the temperature, we are just allowed to increase every hour 40. Yeah, you can increase it by 80, but you destroy, you reduce the lifetime of your equipment. Leakage, low efficiency, fouling, hooking, cracking is the side effect of this one. And also for the pressure shock. Pressure shock. When you are working with the molecular sieve in the dehydration, in the sulfur desiccant in your refinery, if you suddenly reduce the temperature or increase the temperature, the structure of molecular sieve will be destroyed by pressure shock, temperature shock, or maybe free water. If you introduce, when you want to purge some molecular sieve, purge it to be able to keep it safe and put it under maintenance instead of the nitrogen, maybe process air, maybe instrument media, you connect it to the water, utility water. What happened to that? You lost your molecular sieve, you destroy your molecular sieve.